Good morning, students.
Okay, good morning, students. Today we are going to see the topic haloalkanes and arenes and elimination. Today also we are going to discuss about the chemical properties of haloalkanes. And yesterday we started with the chemical properties, the types of nucleophilic substitution, and we discussed about the SN2 and the SN1 reaction. In the same manner, today also we are going to discuss the chemical properties of haloalkanes under the subtopics. Okay, so first let us take the chemical properties. We are going to discuss, already we have discussed about substitution. So today we are going to discuss the chemical properties based on three types. The first one, we are going to take elimination reaction. Second one, reaction with the metals, some of the metals. And third, we are going to discuss about reduction process. Okay, reduction process. So totally chemical properties, the types totally 4. Already just completed, yesterday completed substitution, we leave that one. And remaining 3 properties we are going to discuss now. First one, elimination. Second one, reaction with the metals. Third one, reduction. Is it okay, students? Okay. So first one, let us start with the elimination reaction. Okay, elimination reaction. So first of all, on seeing a topic, the word itself, you can find out something we are going to eliminate from the reaction. Okay, is it okay, Anna? Yes, you find the answer. Same, you are going to eliminate. But what is the condition for an elimination reaction? We are not possible to eliminate for all from all those carbon. So what is the condition for the elimination? So we are going to here eliminate the hydrogen from beta carbon. Okay, from beta carbon. Students, this is a new word. We are using beta carbon. What is this beta carbon? Suppose if I am taking a haloalkane as an example, CH3, CH2, Br. Okay, you take this is your haloalkane, one organic compound, haloalkane compound. Okay, now what is this beta? Okay. What is this beta carbon? We know already. So where the functional group is attached. So here we are continuously dealing with the halo system. Okay. So here bromine is a halide group. Where the bromine attached? Where the bromine attached? This bromine is attached with this carbon. Is it okay? Okay. That carbon I am going to give the name as alpha carbon. What is this carbon? Alpha carbon. Okay. And whenever bromine attached, the first carbon gets a name alpha. The second carbon, because in your compound, first carbon is CH2. Second carbon is methyl. So this is your beta carbon. Okay, then almost one more doubt we can arise this. Suppose if I take one more methyl group, if I take a propyl bromide, so one more methyl group, that methyl group also containing hydrogen. So what is the name you are going to give? That name also we can follow. That is a del. Suppose one more carbon like that, it is going on. So what is a beta carbon? You got it? So beta carbon means where the halide attached carbon gets a name alpha. Okay, and next carbon only beta carbon. So we are going to eliminate the hydrogen from the beta carbon. Okay, now I will show that elimination. Okay, so here this methyl group, that is a beta carbon methyl group. For your simplicity, I can write the hydrogen as like this. Okay, CH3 no, first CH3. Just I wrote C, single bond hand, single bond hand, single bond H. Okay, and next CH2, C, H, and Br. Actually, this is your compound CH3, CH2, Br. Okay, now what is this carbon? Alpha. What is this carbon? Beta. Okay, now comes to elimination. So whenever haloalkanes, okay, reacts with the alcoholic potassium hydroxide, okay, alcoholic potassium hydroxide. This is another reactant, alcoholic potassium hydroxide, in the presence of an alcohol. Okay. Now what happened? From that alpha carbon, I am going to eliminate the Br. This is called elimination reaction. And same way, from the beta carbon consisting of a 3 hydrogen, you take whatever, any hydrogen. Suppose I want to eliminate this hydrogen. Shall I eliminate second, third? Yes, whatever maybe. If you want, you can take whatever may be the hydrogen, but you want to take what? Only one hydrogen. Okay? So no need of taking all the 3 beta hydrogen. That is wrong. So here, between the C single bond Br, okay, from the alpha carbon, I am going to take this Br out. From the beta carbon, I am going to take a H. I am going to take a H. Okay, and what is this H? Actually, H's comes out. Carefully note down. H's comes out as H plus. As H plus. It is not carrying any electron or whatever may be free radical. And whenever you know already starting from the class itself, I mentioned in between carbon and the Br. We know that already 2 electrons for the bond formation, and whenever this bromine is not highly electronegative, so this will undergo cleavation and the shared pair of electron taken by the bromine itself. So this becomes Br minus. Okay, Br minus. Okay. Now you got it? H comes out as H plus. Br comes out as Br minus. Now what is the second reactant we are taken? KOH. So potassium hydroxide, I can polarize, I can split the charges K plus and OH minus. Okay, now you got the product. That is side product only. The H, okay, H plus added with the OH minus. Okay, H plus added with the OH minus. Same way, this Br minus negative added with the K plus as formed potassium bromide and water. This is your side product. Okay, so this is side product formation. You come to the main products where I take hydrogen as H plus and Br as Br minus, just see left in the two atoms in the haloalkane system. Next, what happened to the original molecule? Okay, now you listen. This carbon, okay, this carbon, you know down. In this carbon, okay, one single bond is present. One single bond is present. Okay. Now, in that single bond, okay, carbon, single bond, hydrogen. Now, H comes out, H plus. Now, carbon is free with the one single bond. Now, the free single bond shifted towards the carbon-carbon single bond. So, already one single bond is present. Now, I am going to shift one single bond towards a carbon-carbon single bond. Now, I have added one more single bond. So, this is taken as a double bond character. So, I can write the structure like this. That is C, H, H. Okay. Now, already one single bond. You added one single bond. So, it becomes a pi bond. So, it is a double bond. And next, yeah, C, H, H. This is your product. Okay. So, what is this product? So, I am splitting carbon and hydrogen. Don't confuse. You see, this is CH2 double bond CH2. What is this? CH2 double bond CH2. Okay. So, what is the name of this compound? We know already. This is an alkene system containing how many carbon? 2 carbon. 2 carbon means what is the root word? Okay, H. And this compound is saturated or unsaturated? This is unsaturated. What is the meaning of unsaturated? Presence of a double bond. How many double bonds are present? Only one double bond. So I'll use the suffix word E. So this is how we have to give the name to the compound. Okay, this is ethene. So ethene is a common name or IUPAC name? It is an IUPAC name. So if you write ethylene, it is a common name. So ethylene is a common name and ethene is your IUPAC name. The product name is now ready. Okay. Already we know what is a side product. Okay. So already we just created, okay, potassium added with the Br, potassium bromide. H plus added with the OH minus as water. So this is your potassium, okay, bromide. Okay, potassium bromide. This is called a simple elimination reaction. Okay, so where I have taken a hydrogen from the beta carbon, right? Hydrogen from the beta carbon. So I can name this reaction as simple beta elimination. What is the name I am going to give? Beta. This is called beta elimination reaction. So instead of taking this haloalkane ethyl bromide, you can take propyl bromide, butyl bromide, whatever may be, but you should concentrate only on the beta carbon for the removal of a hydrogen. Then it is okay. So clear this reaction. Next. So in the last equation, we discuss about elimination and we are not bothering about one carbon containing halide group and next carbon we have taken a hydrogen. Suppose if your haloalkane is like this compound, I will give you one more example. So this is a second example you take CH3 CH Br. CH3. Okay, you take this compound. This is also hydroalkane. Okay. Now, when we look this compound, one thing you notice, Br is not in the terminal. Terminal means starting at the ending. But the Br here is non-terminal. One point. It is very, very clear. And where I am going to take a hydrogen. Where I am going to take a hydrogen. Okay. So, whenever this is your alpha carbon means there is two possibilities. Left side also one carbon, next carbon beta. Right side also that carbon beta only, because I can move the compound like this, the left side and the right side. There are two possibilities for a non-terminal halide groups. Okay. So for this compound, suppose if you are getting like this halo compound, how you are going to do the elimination reaction and what can be your product form and which can be taken as a major product, and now you are going to discuss. Okay. So first, what is the name of the compound? Have you guessed? Because first carbon like this is your first carbon, this is here, second carbon, third carbon, fourth carbon. How many carbon? 4 carbon. Okay. And hydrogen, we know how to calculate 4, 5, 6, 7, 8, 9 hydrogen and 1 Br is present. Okay. Now second question Br. So prefix 2 bromo. Prefix is what? 2 bromo. How many carbon? Root what? Butes. Because 4 carbon means bute. And whether your compound is saturated or unsaturated, your compound is saturated because your compound is containing only single bond between carbon and carbon. How many bond I put? Only one bond. So it is a single bond. So their compound is saturated? Yes. So saturated means A. This is how you have to give the name. 2-bromo-butane. Okay, now you take this compound. So now I am going to do the elimination reaction. Okay, one thing is very clear. I have 2 beta hydrogen. Okay, so from that we can get one point. There are 2 possibilities for the reactions. Okay, so I will show the 2 possibilities now. Okay, this is one process. This is the second process. Okay. Now, whenever this haloalkanes reacts with the alcoholic potassium hydroxide in the presence of potassium hydroxide, this will undergo elimination reaction. Now, what is this elimination reaction? Okay. So, sure, from the alpha carbon, so first process, I am going to take this beta carbon. First process, I am going to take this beta carbon containing hydrogen. Okay, so is it clear? So, we know that here almost CH3. I want to eliminate one Br from the alpha carbon. Okay, now this I can write this as, okay, already CH3 no. Suppose for your simplicity, I want to split like this, CH2 H. So what is this? This is also CH3, but I wrote one hydrogen as separate. This is only what important step. Just you have to split the compound when you are writing, because I want to show the double bond. So that only I wrote like this. CH3, you write C single bond hydrogen. Okay. Now, what is the first step process? I'm going to eliminate BRS, Br minus, H as H plus. This is as H plus. This is as Br minus. Okay. And this reactant K plus and the OH minus. This Br added with the K, will get KBr, and this H plus added with the OH minus becomes as a water molecule. This is your side product. Okay, then comes to the main product. So if I take from that beta carbon, I took the hydrogen, just I'm eliminating the hydrogen. Okay, now this free bond, I'm going to shift like this as a double bond. Elimination, all elimination reactions same way only, but you should remember which compound and how I am going to perform that reaction. That's all. So just shift the single bond as a double bond. Okay. Now you assume that this can be entirely, I can write like this. The first carbon CH2 because I eliminated how many hydrogen? One. Okay, already one single bond. Now I am adding one single bond. Becomes a double bond. Second, CH. Okay, CH. Third carbon does not change. CH2. And fourth carbon, CH3. Is it clear? Okay, CH3. Okay. Now this is your first pathway. This is first pathway. Okay. So first step, left side, I took the beta hydrogen, left side carbon. Okay. Now in the second process, you go with the right side. This is second beta carbon. This is your what? Second beta carbon. Okay. Now I am going to concentrate. Same this Br I'm going to eliminate because okay in the second step also same thing. Suppose for your understanding, I'll write the one more the term like this CH3 CH okay second carbon Br and this carbon CH2 is CH2. We'll split that CH2 as just I'm splitting. Okay. Listen. C H H. Got the remainder. Got it? And same way CH2. The same compound. For the first pathway, I took a beta hydrogen from the beta carbon. Okay, one left side beta carbon. Now I am going to concentrate right side beta carbon. This is your second pathway. So you left this methyl group as it is. Okay, don't disturb that methyl group. You go and concentrate the right side beta carbon containing hydrogen. Okay. Now what happened? This Br comes out, Br minus. This H comes out, H plus. So is it clear? Okay. So whenever if you add K, KBr will be eliminated. If you add hydroxyl ion, H comes with a hydroxyl ion and it will be eliminated as a water molecule. Now the bond, the free bond length, that will be shifted towards. Okay, this product only I am going to write it here in step 2. Students, I am clear? Okay. So in the second step product, I am going to write here. Okay. So this as the first methyl group, no disturbance. And same way, second group, just we have taken what? Bromine. So CH is remaining. And next, already one single bond. I am going to add a one single bond, and that becomes a double bond. And here, CH, CH3. Look out. The two products, okay, the same elimination reaction, but I took two pathway. Okay, in the first step, just I'm concentrating left side beta carbon. In the second step, just I'm concentrating the right side beta carbon, but I have entered with two different products. But on seeing the product, you can find out miss the carbon number is same. But what is the product name? It is entirely different. So yeah, first carbon, second carbon, third carbon, fourth carbon. So this is unsaturated because double bond. Where the double bond portion first. So 1, Okay, I'm going to indicate one. So totally 4 carbon. So totally 4 carbon means bute. Bute is what? It is a long chain, indicating long chain. And saturated or unsaturated? This is unsaturated. That's why E. So the name of the compound is what? 1-butene. Likewise, can you see the second compound? First, you give the number of the compound. 1, 2, 3, 4. Where the double bond is located? In the second. Because don't say like third. So only always least number only, because the double bond is shared between second carbon and third carbon. So no problem. But least carbon number only we should take. So this second carbon. So 2 like that. 4 carbon. So the root word you can take bute as it is. Whether your compound is saturated or unsaturated. Unsaturated. So use E. That's all. Okay. The first pathway, the product obtained is 1-butene. The second pathway, the product obtained is 2-butene. Okay, so we can take the two products now. But this product, okay, this product, among this, which one be acting as a major product? Which one acting as a major and which one acting as a, okay, minor products? Okay, we are in confusion. So for to simplify this confusion, and scientists named Saitsev. Okay, Saitsev. He has given a new rule. That rule name only Saitsev rule. Okay, what is this rule? You go and concentrate the carbon-carbon double bond. Where the carbon-carbon double bond. Which alkene? Because carbon-carbon double bond is what? Simply, we can say it is alkene one. The alkene more substituted alkene only acting as a major product. You got my point? So more substituted alkene only acting as a major product, less substituted alkene acting as a minor product. This is the rule. Now I am going to apply this rule for the two products. I am going to find out which one is major and which one is minor. Okay, comes with the 1-butene. Because I don't know what is called substituted. We are even more substituted. What? How to know that? Very simple. You take the first compound, 1-butene. Okay, so 1-butene, where the carbon-carbon single bond here. Okay, carbon-carbon like this. No, this is a double bond. So first in CH2, how many H? 2H. We split like this. Okay, 2H. Carbon-carbon double bond. Second carbon containing only 1 hydrogen. And third carbon containing 2 hydrogen. And your fourth carbon containing 3 hydrogen. No problem. Is it clear? Is it clear? Okay. Now listen. First carbon, okay, in the first carbon, how many groups are attached? If you take, how many groups are attached? Okay, so if you take the first carbon, only 2 atoms. First one atom is 1 hydrogen. Second atom is 1 more hydrogen. So 2 atoms are only hydrogen. Now, this is the first carbon, second carbon, I write. For your clearance only, second carbon. This is, you take second carbon. In that second carbon, so for your simple, I write like this, 1 hydrogen. Okay. 1 hydrogen. C and this group like this. Ethyl group. Okay, so listen, this is your structure. First product 1-butene. In that 1-butene, 1 carbon attached with the 2 hydrogen. Just I wrote 2 hydrogen. Carbon-carbon double bond. Second carbon containing 1 hydrogen, 1 ethyl group. Just I split the compound. That's all. Okay, this is the first product. Now you take a second student. The second product also carbon-carbon double bond. Where? Okay, this is carbon-carbon double bond. First carbon containing one H, containing one methyl group, because this is your first 2 butene as a second product. In that, okay, the first carbon-carbon double bond, one carbon containing hydrogen, and the second group is methyl. Likewise, you have to don't concentrate from the first carbon, because you should focus on the carbon-carbon double bond only. That's why I wrote carbon-carbon double bond. Then only you have to split those groups which are attached to the okay. So H methyl group, and your next carbon also H methyl group. Okay. Now, what is your Seltzer rule? Alkene, more substituted alkenes, that leads to major products. More substituted alkenes that leads to what? A major product. Okay. Now you look out those two structures. Which will be more substituted? So here, okay, here in the first compound, okay. So here 2 atoms. It is not a group, but only one group, ethyl group in the first carbon. In the second product, okay, if you take second product, first carbon containing one methyl group and one atom. This is not a group, okay. And second carbon also one atom of hydrogen and one group, methyl group. So here only one group substituted in the first compound. In the second compound, 2 alkyl groups are substituted. 2 alkyl groups. So now we say which compound is acting as a major? Only 2 butene, because more substituted. That's why this 2 butene as a major product. And 1 butene acting as a mono product. Will be the percentage appearance will be very, very less. Okay. So simple alkene product. If it is substituted alkene, then 2 products make it. So to among the 2 products, which one is major, that will be defined. Okay. So now next step, we are going to see the type of elimination. Okay, okay. Here also we are going to see the types of elimination. So under the times, okay, there are 2 types of elimination reaction. One is E2, that is molecular elimination. Okay. And another one is E1, that is unimolecular elimination. Okay. First one is E2 and second one is E1. So you know that molecular elimination is first E2. Okay, the haloalkane. Suppose for example, I can take CP, H2, H2, yeah. Okay, this common name is H3, H2, H2 as a volume. So indicating straight chain, I can give you N propyl bromide. N represents what? The compound is straight chain. N propyl bromide. Okay. Now, this haloalkane is going to react with the potassium hydroxide. Potassium hydroxide. Okay. Now, what is elimination? What is elimination? I'm going to eliminate the hydrogen from the beta. Immediately go search where atoms of carbon, where beta carbon. Okay. So Br attached carbon alpha. The next carbon here beta. Okay, I told you already. If one more carbon will be acting as a delta. So no problem. But we have to concentrate on the beta carbon. Okay. So now this is your beta carbon. Okay. Now in the beta carbon, the hydrogen, how many hydrogen? 2 hydrogen. Now I am going to represent the 2 hydrogen like this. Okay. C H H. Is it okay? CH2, I write what? C single bond H, single bond H. This is your what? Beta carbon containing hydrogen. Okay, now what you are going to do? From the alpha carbon, I am going to eliminate a bromine. From the beta carbon, we are going to eliminate a hydrogen. Okay, and your alcoholic potassium hydroxide can be split at A plus and then OH minus. Okay, now this Br leaves us Br minus, and this will combine with the same step only. Okay, but it is mechanism. Okay, and next same way one hydrogen, any one hydrogen you take. Okay, so one hydrogen, okay, this hydrogen comes as H plus, and this will be added with the OH minus, becomes a water. Okay, this is a side product. Now we go with the main product. So I can hydrogen, right? Okay, now this one bond has been on. That bond I am going to shift it to carbon. Then you can write the product like CH3, okay, C H double bond CH2 plus, already we know side product, potassium bromide plus water. This is clear, plus water. Okay. Now, whenever if you do the E2 elimination reaction, just you are getting a product. Just we have started with the reaction with the 3 carbon, so we should give a name to the product. So double bond where it is located from the first carbon, it is the second carbon, it is the third carbon. So one root word for 3 carbon, prop, okay, and double bond system. So E. Okay, one propene as a product. This is your E2 elimination pathway. Same, what is elimination? Same condition we are going to apply here. Okay. And if you take the rate of that reaction, okay. So you know already how to take a rate because we are seeing SN1 and SN2. Like the rate of the reaction. So what is rate? Almost rate is depend upon the concentration. Rate is depend upon what? Concentration. How can I write the rate? Yeah, the rate depends on what? Depends on what? Okay. So it is just based on whether a reaction occurs in single step or multi-step. Whether all reactants are involved. Those things you have to concentrate to write the rate. Okay. So you see first. Here I have taken one reactant as N-propyl bromide. Another reactant as potassium hydroxide. Whether I have involved all these 2 reactants? Yes. Okay. So S. So N-propyl bromide also involved and potassium hydroxide also involved. So this reaction, the rate depends upon the concentration of a 2 reactant, and one is N-propyl bromide, one reactant N-propyl bromide, and another reactant potassium hydroxide. Okay, so the rate depends upon the concentration. So that's why I will do the square bracket. This represents concentration. Okay, So the concentration of a N-propyl bromide and the concentration of a potassium hydroxide. So it follows because in rate determining step. So it occurs in how many steps? Single steps. Single step process. The rate determining step. How many reactants are involved? 2 reactants. So that's why it follows second order reaction. You know what is second order reaction? If the rate of the reaction is depends on the concentration of a 2 reactant, then it follows what order reaction? Second order reaction. This is called the E2 reaction mechanism. Okay. So E2 reaction means what? It occurs in a single step. Single step, and the rate of the reaction depends on concentration of N-propyl bromide and the concentration of potassium hydroxide. On the whole, it depends upon the 2 concentration. That's why we took second order reaction. Okay. So next one, we'll move with the second type. Okay. Second type. That is E1. So E1 elimination, on seeing that one, it is called a unimolecular elimination, and this elimination reaction occurs in 2-step. 2-step process. Let's see what is first. For the E1 elimination, I am going to take a tertiary system. For E2 elimination, I took only primary system. For that E1, I am going to take a tertiary system. Okay, tertiary alkyl halide I am going to take. For example, in step 1, I am going to take a tertiary alkyl halide. We know tertiary alkyl halide, CH3, CH3. You know already what is tertiary butyl group? This is your tertiary butyl group. Tertiary butyl bromide. The name is tertiary bromide. In the first step. So what is step 1? So first step, just eliminate the BR. Okay, group is that in your book they are given heterolytic fission or heterolytic cleavage. Okay, heterolytic cleavage of CBr bond. You know already CBr bond. So here one electron from the carbon, one electron from the bromine. Heterolytic cleavage means shared pair of electron taken by a similar. That is called the heterolytic cleavage. Okay, so whenever the shared pair of electron taken by any one of the atom, the bond nature. My cell phone.
அவங்க அன்மியூட் பண்ணலாம் அவங்க பண்ணலாம் sometimes.
So students, sorry for the disturbance. Tertiary butyl bromide. Okay, now what happened? So here in tertiary butyl bromide, okay, heterolytic cleavage. When you are doing heterolytic cleavage, what happened? This Br becomes as Br minus, and C becomes a C plus. Okay, so here what happened? CH3, C plus, CH3, CH. This is tertiary butyl cation. This is what a tertiary butyl cation. This is the product obtained in the first step. Okay, this product appearance occurs very slow manner. Okay. Now what happened? This is step 1, electrolytic cleavage of a tertiary butyl bromide gives tertiary butyl cation. Okay, so in the step 2, what we are going to do? Okay, in step 2, now only the attack of nucleophile taking. That is, if you take the carbocation CH3, CH3, okay, so the purpose of removal of beta proton, just I am writing one CH2 as like this, okay, one H. Next CH3, like this positive. Okay, this is carbocation. What is the name of the carbocation? Tertiary butyl cation. Okay, now it reacts with now only the second reactant, alcoholic potassium hydroxide. Okay, so now what happened? So here, first step we have taken the Br. The second step, just we are going to abstract the beta carbon hydrogen. Okay, so now this OH minus, okay, and H combined as water. This H comes out water, H plus. Now the single bond, no, this single bond is free. Now this single bond shift towards this carbon-carbon single bond as a double bond. So this becomes CH3 C double bond CH2 CH3 okay, and almost we are knew that first step bromide, okay, that bromide added with this K, so this becomes as KBr, potassium bromide. Okay, now is it clear? The first step, just we are taking a bromide. The second step, we are abstracting a proton from the beta carbon. Okay, so now what happened? Actually, this attack of here OH minus taking of beta carbon occurs as a fast reaction. Occurs at what? A fast reaction. Okay, we know that the rate of the reaction depends, or for determining rate, we are going to take only the slow process. We are going to take only the slow process. So here the rate of the reaction, that is the rate depends on only the concentration of alkyl halide, not a second reactant potassium hydroxide, only alkyl halide. So the E1, okay, E1 elimination, the rate of the reaction depends on only one alkyl halide. So it follows first order reaction. It follows what reaction? First order reaction. Okay, so the rate is depending on the concentration of only one. So it belongs to the first order reaction. So is it clear? So E2 means single step. It follows a bimolecular mechanism, and the order of the reaction will be second order. E1 means it occurs in a two step, but the step 1 is a slow process. Step 1 is what? A slow process, and step 2 is a fast process. So rate depends upon only step 1. So it depends upon the concentration of only alkyl halide, and it takes a first order reaction. So now that is the difference between E1 and E2 reaction. Okay. So E2 reaction most favorable for a primary alkyl halide, and E2 reaction most favorable for a E1 reaction for a tertiary alkyl halide. So E2 means you have to concentrate primary alkyl halide, and E1 means tertiary alkyl halide. Okay, and next, so we have completed elimination reaction, and next third one we are going to see reaction with the metals. Okay, reaction with the metal. In reaction with the metals also, I am going to categorize this reaction with the metal as two types. One as formation of a Grignard reagent. Formation of a Grignard reagent. Okay, is it okay? And second one, reaction with the active metal. So probably Grignard reagent also we can take less reactive metal. Next we are going to see the more reactive metals. Okay. So first one, if you take Grignard reagent reaction, if you take any alkyl halide, okay, CH3, CH2, Br. Okay. So now what is this alkyl halide? This is your ethyl bromide. This is what ethyl bromide. Now this ethyl bromide reacts with less reactive metal like magnesium. You know magnesium as symbol Mg. Okay. Now what happened? This gives a product in the presence of a dry ether. Just we are taking hydroalkane and mixed with less reactive metal like magnesium and this. Okay, pass through the dry ether medium. Now what happened? You are going to get the product like this: CH3, CH2, MgBr. This is named as ethyl magnesium bromide. Okay, ethyl magnesium bromide. This is called a general Grignard reagent. You may ask, Miss, ethyl magnesium bromide only Grignard reagent? No. Instead of ethyl, if you take, I will give you R. Okay, R, Mg. You take any type of ion. This is called the Grignard reagent. Okay, so ethyl magnesium bromide. Okay. Next, this reaction. Next, reaction with the active metal. Okay. Reaction with the active metal. Reaction with the active metal. Okay. Now, active metal means there are two metals I can take. One is lithium. Okay, and the other one is we can take lead with the sodium like that. Okay, so first one, if you take CH3, CH2, Br reacts with the lithium. Reacts with what? Lithium. Okay, now what happened? Whenever it reacts with the lithium, lithium as a reactive metal. So what would be your products? Okay, what would be your products? So now you guess this product here. Okay. So now what happened? One lithium should be added with the ethyl group. So CH3, CH2, Li. Okay. And Br should be added with the one more lithium, Li, Br. Now to maintain the balance equation, I will put here 2 Li. Okay. So this is ethyl lithium. Ethyl lithium. This is lithium bromide. Lithium bromide. Okay. Next. Okay. Next, same ethyl bromide I'm going to take. CH2Br reacts with sodium in lead. So very reactive metals. Just we are taking sodium in lead. Okay. So whenever ethyl bromide reacts with the lead, you will get a product like this: CH3, CH2. Okay, 4 times tetra ethyl lead. Tetra ethyl lead. And the sodium and the Br combined sodium NaBr. This is your product. Okay. Now while I am balancing that equation, you will get one more product. So we should write lead also. I will tell you okay how it is possible. Okay, now listen. I wrote tetraethyl. So this 4 no. If I mention 4 here, in the reactant side also I should mention. When I am mentioning 4, okay, here also bromine 4 times. So bromine 4 times means from the product side I should indicate 4. So now bromine is ready. While I am writing here bromine, again I have to go with the sodium. So sodium also 4. If I put 4 here, 4 sodium is balanced, but what about lead? Here only 1 lead. Okay, so for that balancing only, I put 3 lead here. Is it okay? So this name is tetra ethyl lead. Okay, tetra ethyl lead. This is called a reaction with the active metal. Okay. If you take the last reaction, reduction. Okay, reduction. So whenever this haloalkanes, okay, haloalkanes, reduction with the hydrogen. So in the presence of nickel and the palladium. So reduction with the hydrogen, we are going to use two. One is CH3, CH2Br. Okay, undergo reduction in the presence of nickel. Okay, or we can use palladium. Okay, at a temperature of 523 Kelvin. The temperature of water 523 Kelvin. It undergo reduction. Okay, so reduced into okay, one alkane. So this H and Br combined, and one hydrogen will be added to this CH2 group. So this becomes CH3 plus okay plus HBr. Okay, and one more reduction process we can write by using of a hydrogen ion. CH3 CH2 Br ethyl bromide reduction by using hydrogen iodide in the presence of red phosphorus. We know this is complete reduction. Okay. Now what happened? This H, you know, H plus ion minus. This H will be added here, and this Br will be added. Okay. So here we'll get a product one alkane. Okay. So one alkane CH3, CH3, CH3 single bond. Okay. So you'll get CH3 single bond. Okay, so this is your alkane. What? Ethane. Okay, and your side product HBr. So ionic Br. This is your interhalogen compound. Okay, bromo iodide. And just on looking this reduction, haloalkanes. Generally, haloalkanes are reduced into water alkane. Okay. So today, just we have taken all those things. Okay, one is elimination reaction completed, and second one is reaction with the metals completed, and third one reduction process. Last, we have to see the uses. Okay, so uses we know that is compound like we know already used as chloroform. Okay, chloroform you take. It is used as a pesticide and preservative. Pesticides and preservative also. We know for a biological purpose. It is used as a preservative for a biological purpose. Okay, so for that purpose we can use the chloroform. If you take the iodoform, compound of this haloalkene, iodoform, it is used as antiseptic. Antiseptic, you know, antiseptic. And carbon tetrachloride is used as a solvent for the extraction of drugs, oils, etc. So drugs and oils. And one more thing, if you take this carbon tetrachloride, non-combustible, okay, non-combustible, and because of this nature, it is used under the name of pyrene. Pyrene in extinguishing oil under the name of pyrene. Okay, so this is uses of haloalkanes, chloroform, iodoform, and then carbon tetrachloride. Carbon tetrachloride, we know this is an nonpolar solvent that we used to read in some of the areas, but non-combustible, that is under the name of pyrene to extinguish oil fire. Okay, so today we have discussed about what? Only elimination, reaction with metal reduction. So elimination, what are the two types? E1 and E2. E2 occurs in how many steps? Only one step. E1 occurs in two steps. Okay, E2 follows what mechanism? First order kinetics. E1 follows what mechanism? Second order kinetics, like that. And reaction with the active metal, what are the metals we are concentrating? Magnesium and nickel or palladium also just we are using. And one more very active metals like lithium we are used, and lithium we are used, and sodium in the presence of lead, just we have taken what? A tetraethyl lead. And the process reduction, just keep it near mind, haloalkane reduced into what? Alkane. Okay. This reduction carried out in the presence of hydrogen and hydrogen iodide. Last, we have seen the uses. Okay, now students listen. If you have any doubt, if you want, you can share your doubts to me. Okay, and we know that this is all equation type. Okay, please, while you are listening to classes, it will be what very clear to you. Okay, I'm seeing the classes itself. But while you are reading the book, you may have some doubts. Okay, those doubts you can ask me, and I will clarify. Okay, so think I have cleared you. Thank you.